Welcome to your teaching session on lung volume. So this is a common respiratory physiology topic. So let's start. So here we have a diagram of a lung volume graph. So as you can see on the y-axis is volume in milliliters or liters, and then on the x-axis it has this time in seconds. There's different components to this graph. So if we start with this here, so this represents the tidal volume, and this can be between 400 to 600 mils. So it depends on the body weight and the size of the person. So this small waves here represents the tidal volume. Next, let's talk about the expiratory reserve volume, so which is represented by this area. And then you have the actual reserve volume, which is right at the bottom. And that is about 1.2 to 1.5 litres residual volume. And the expiratory reserve volume is around 1,200 mils. So the tidal volume is the normal resting breath volume, so it's what you breathe in. The expiratory reserve volume is the volume of air that can be expired from end of a normal tidal volume, so it starts at the end. And then your residual volume is the volume that is remaining in the lungs after maximal expiration. Next, let's talk about the inspiratory reserve volume, which is represented by this area. So this is the volume of air that can be inspired over and above the resting tidal volume. And this is about 2,500 mils, around that much. Then we have the FRC. So FRC is represented by this. So as you can see, the FRC is made up of the residual volume and the expiratory reserve volume. And the FRC is the volume of air that remains in the lungs after normal expiratory breath. Okay, now there's two more things that were left. One is the vital capacity, so which is represented by this area. And the vital capacity is about 4,800 mils. And that's the maximum volume expired after a maximal inspiration. The FRC is around 3 litres standing up or 2 litres supine. There's several things that affect the FRC, and it's really important in anaesthetic practice. So now we have the whole thing, which is the total lung capacity, which is around 6 litres. And it's the total volume of air in the lungs after maximal inspiration. So in this graph and in this section of the volumes, the total lung capacity of the residual volume and the FRC cannot be measured by simple spirometry. So that's anything that incorporates residual volume. And to measure these, you need to use other methods, such as body plethysmograph or helium dilution or the Fowler's method. So just to recap the graph, so we have tidal volume, which is represented by these small peaks. Then we have expiratory reserve volume, which is from the end of the tidal volume to residual volume. Then we have inspiratory reserve volume, which is from the peak of the tidal volume to the maximum total lung capacity. And then we have the residual volume here at the bottom, and FRC, which is a combination of the expiratory reserve volume and the residual volume. And then we have vital capacity, which is represented here, and then the total lung capacity. Thank you for listening, and I'll see you for the next video.